Now, what's really nice about vector equation line is it works so well to go to 3 dimensions. Everything is exactly the same. You just need to find a direction vector, and you need to have a starting point. Where we didn't really have a good way of having a rise over run over roll for our new slope thing for 3 dimensions. But the vector equation, the direction vector, sort of gives us that. And you don't have to use t. For whatever reason, t is the parameter that's used first. If you have two equations that have different parameters, the next letter they use is s. So you'll most often see vector equations with t's and s's as parameters. For our direction vector, do you see that you have to figure out what p to q is? And so we're going to need to go negative p and then add q. Thank you. And when we add those together, we're going to get 1, negative 5, negative 7. So that is the direction vector. And our point, you could choose either p or q. For parametric equations, if you wanted to write them out, you would have x, y, and z. So now we ask ourselves the question, does this point lie on the line, or doesn't it? Now, the same thing we've done in previous questions of if you were asked if a point lies on a parabola, or if a point is on a cubic function, or if a point is on a line, you always plug that point in for x and y. In this case, we're plugging in a point in for x, y, and z, and then you're seeing if it works. If it makes the equation true, then you know that it's on the line. If it doesn't make the equation true, then you know it's not on the line. So how does that work with a vector equation? Well, we're going to put in the negative 1, 3, 5 in for our vector, because our vector equation, this could be any point on our line. Okay? And every point that's on the line, there exists some t which makes it true. So now, if we have that, we have 1, 5, 3 here, plus t, and then over here, just going back, 1, negative 5, negative 7. And we're basically asking, is there a value for t where this works? Because if there's a value for t where this works, then that point is on the line. But if there's no value for t where that works, then that point is not on the line. If we look at our parametric equations, well, that means our x-coordinate needs to equal 1 plus t. Our y-coordinate says that three would have to equal 5 minus 5t, and our z-coordinate I guess I can just make that subtract 3 minus 7t. These aren't hard equations to solve. What would t have to be for the first one to be true? T would have to equal negative 2. So if negative 2 works for all of them, then that point's going to be on the line. But when we go to the second one here, and we solve for t, we get 2/5. At this point, it's enough information to say that it's not on the line. And with the last one, if you'd solve for t, you get -2/7. If there was a value for t where it worked, that value of t would have to be the same for all of those. So that in order to get to that point, you'd plug in t equals 2 or -2, and each of those coordinates would match up. That would tell you that if you started from some point on your equation of your line and went back the portion of your direction vector, you'd get to another point on your line. Any guesses? You think it's going to be on the line? Okay. Three, -5, 5. Oh, I should memorize this. 1, 5, 3. 1, -5, -7. Here t would equal 2. Here t would equal 2. And here t is equal to -2/7. So a good math teacher would show one example where it doesn't work and one example where it works. I showed you 2 examples that didn't work. I don't know. This one came closer, right? You felt like you were on the right track, that t is going to equal 2, t is going to equal 2. But this is not on the line. Yes? If we're looking, if 2 vectors are parallel, are you looking at, what do you mean by your 2 vectors? Are you looking at your position vectors? Because your position vectors should never be parallel. Or are you looking at whether your new point with your starting point is parallel to your direction vector? Then yes. So could we say a point that would be on the line? What would it have to be for 2 to work? It would have to have been 3, -5, and then 3, -5, and then if this one was going to be a 2, you'd have 3 plus 2 times -7, -11. That would be a point which would be on the line. But the other ones are not.